Hey, this is Mr. Milleman, and I'm back to talk to you about electrons. Well, remember when we talked about atoms? We talked about the different particles within the atoms. We talked about protons and neutrons. They're in the nucleus, and the electrons float around outside. Well, here we go. Let's start talking about these little guys and what they can do for us. Electrons are found in different levels or rings. These electron levels will determine a lot of different things, and it also determines where you can find an element on the periodic table. Within every different atom, we have electron rings. Well, the electron rings are determined by how many electrons are in that element. Well, the atom, this one is made of hydrogen. It's got 2 protons, 2 neutrons, and 2 electrons. Well, as you can see, the protons and the neutrons are in the nucleus, in the middle. Well, the electrons are circling around on the outside. This picture is a little simplistic, and it's not really accurate, but it gives us a good idea of what we're talking about. The different levels show us the different electrons and where they're located. Here we have 2 electrons, and they're pretty close to our nucleus, but they're not right on top of it, and they surround the atom. And they keep circling in different patterns, not necessarily in that same orbit, that same circle all the way around every time. So it'll change a little bit. When we get a different atom, we'll end up with more rings as we get more and more electrons. Here we have beryllium, 4 protons and 4 electrons. Well, we can only have 2 electrons on the innermost energy level, and we'll end up with the next 2 on the outside. And every time that we get more electrons, we'll eventually get to a larger ring when we get to certain levels, but we'll talk about that later on. Now, the electron levels, or rings, they come in all different sizes, and that's because every atom comes in different amounts of protons and electrons as far as within their element. So, let's take a look at hydrogen. Hydrogen is going to have 1 energy ring. It's going to have 1 proton in the middle, and it's going to have an electron on the outside. So that 1 electron is going to orbit around the 1 proton. It's got 1 proton, 1 electron. Okay, let's change it up to hydrogen. Now, hydrogen is a little different. It's got neutrons. We're not going to bother to show them. You know that they're in the nucleus. They're here in the nucleus with this second proton as well. And it's got 2 electrons orbiting around. Now, when we get to lithium, we're going to have to change things up just a bit. Well, lithium has that 3rd proton in there, along with the neutrons. But it's got a 2nd energy level. And that 2nd energy level is there because the 1st energy level, the inside energy level, can only hold 2 electrons. It can't hold any more. So it's got the 3rd electron on that 2nd energy level. And anything that's going to have a 2nd energy level, the electrons are going to be there. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, they all have their electrons in that 2nd energy level. It can hold a total of 8. So let's just throw them in here real quickly to see where they would go. So all the way up to neon, which has 10 protons and 10 electrons. 10 protons in the nucleus and then 10 electrons on the outside. Once again, you can only have 2 electrons in that 1st energy level. The 2nd energy level can hold a total of 8. So we have 8 showing there. Once we get past neon, we're going to go to a 3rd energy level. So we'll get out here on a 3rd energy level. So when we get to sodium, 11 protons, 11 electrons, we're now going to have that 11th electron, but it's going to be on the 3rd energy level. Once again, 2, 8, and then 1 on the outside. So once we get past sodium, we're going to then move on. So we've got 12 and 13 and 14 and 15 and 16 and 17 and 18. So that 3rd energy level will also hold 8 electrons in it. And each energy level can hold a different number. This 1st energy level holds 2. then we go to 8, then we go to 8 again. Then in the 4th energy level, we get 18. Then in the 5th energy level, we get 18 again, and it just keeps going on. Now, like we talked about, we've got those 11 electrons orbiting around the nucleus of our sodium atom. Sodium has 11 electrons on the inside. We've got 2 on the first ring, 8 on the second ring, and then that third ring has 1. It's not full, but we put all the extras in that third ring because it's not full yet. Over here, what we're showing is just those outer ring electrons, the valence electrons. Now, this is what we call the Bohr diagram, and this is what we call the Lewis structure. In the Bohr diagram, we're showing all the electrons. In the Lewis structure, we're only showing the valence, because for the purpose of bonding, that's the only thing we care about. The valence electrons. What's on the outer level? What can we use? Now, the key to bonding is to be happy. And doesn't everybody want to be happy? Well, atoms want to be happy too. So they want to be happy. Well, how do atoms get happy? Well, they have an outer ring that's full. If we look at the noble gases, their outer ring is already full. They're already happy. They don't need to do anything else. They have a full outer shell, and that's why they don't bond with anybody. They think to themselves, we've got what we want. Why do we want to change? So they don't. But somebody like sodium's thinking, I'm not so happy with this 1 electron on my outer ring. I want to do something about it. So what sodium does is sodium tries to find a buddy. So what sodium does is he goes and finds his old pal, chlorine. And when sodium and chlorine get together, we get table salt, sodium chloride. Well, how does all that work? It's kind of crazy. Well, sodium's got 1 electron on its outer shell. Chlorine's got everything but 1 electron. It's got 7 on that outer shell. So it's thinking to itself, I really want to find 1. Sodium's thinking to itself, I'd love to give up 1. So what they do is they meet up and they say, hey, let's get together and we'll solve both of our problems. Well, if you're thinking to yourself, what's sodium going to do? It's got 1 on the outer shell. If it gets rid of that 1, then it's down to 0. And then it doesn't have a full outer shell, it's got an empty outer shell. Well, that outer shell just disappears. If the outer shell is empty, it disappears and it goes down to the next inside energy level. So in this case, it would be the 2nd energy level for sodium, where it's already got 8 and it's full, so it's happy. So this electron goes over here to chlorine. Full outer shell, we're happy. This electron right here is gone. The outer shell is empty, so it disappears. Outer shell is the one on the inside. It's full. We're happy. Everybody's good. So now that everybody's happy, we've moved that electron over. Full, full. We've made a bond. And that makes us happy. So when this bonding occurs, where the sodium atom gives the electron to the chlorine atom, we get what we call ionic bonding. Ionic bonding is the transfer of electrons from one atom to another, from one element to another. So we're giving it up here, we're getting it here, everybody's happy. Now, when this happens, we end up with an ion. And in an ion, we end up with a positive ion here and a negative ion here. And so our sodium is going to be written like this with a positive, and the chlorine will be written like this with a negative. And what this represents is that sodium has positive. It's now got more protons than electrons. It's now got 11 protons and 10 electrons. Because remember, it gave 1 away, so now it's lost 1. So we have more protons than electrons. In the chlorine, we have 17 protons. And remember, it got 1 electron, so now it has 18. So we have 17 protons and 18 electrons. So now we have 1 extra electron, so it's got 1 extra negative charge. So that extra electron gives it the negative charge that we've got showing right here. Now, another way that elements can become happy is by sharing. And it's a little bit different than giving away. Well, sharing is just what it sounds like. We're going to share our electrons. And H and O form this great substance called water in which they share. Let me show you how it's done. First of all, hydrogen has one proton and one electron. Well, it's only got one electron, so it's not real happy. Same thing down here. Our oxygen, it's got 8 protons. It's got 8 electrons. Well, if you notice, it only has 6 electrons here. Remember, there's 2 electrons in the inner ring, and then there's 6 on the second ring, its outer ring. So what it's going to do is it's going to share. And so we're going to share here, and we're going to share here. And what that's going to do is, remember, hydrogen only needs 2 on its outer ring, its first ring, to be happy. So it's going to share one here, and then this hydrogen is going to share one here, and then oxygen, it's going to have its 6. Plus, it's going to share with these 2 hydrogens. And so in the end, the oxygen and the 2 hydrogens together are going to join together into H2O, water. So here's our water molecule right here. We've got the H bonding here, and it's going to bond within this ring. And the H is going to bond here, once again, within this ring. And then your oxygen is going to be this. So you end up with hydrogen and its 2 electrons, hydrogen and its 2 electrons, oxygen and its 8 electrons. We shared. Everybody gets what they want. Everybody's happy. And if we turn our molecule into a different pattern, look what we get. Look what it looks like. Kind of funny with that mouse ears going on, huh? But that's really what a hydrogen molecule looks like in the real world. They're very tiny, and seeing a molecule is really hard. But that's the shape of it. Kind of cool, huh? Now, the molecules, once they form, they're not the same as they used to be. Because our water, we all know what water is. It's this great liquid. Well, hydrogen and oxygen on their own, when they're not part of a molecule, are very explosive, very flammable. And in fact, NASA uses them to launch rockets into space. That's that space fuel. Well, rocket fuel, water, they're not the same thing. So when we have the chemical reaction and we form a new substance, the water, something different altogether. It's not the same stuff. It's something very different altogether. Metallic bonds are formed by the positively charged metal ions and the electrons in the metal. Metallic bonds allow electrons to conduct electric current. And the valence electrons move through the metal wires because they're not connected to any one particular atom. You hear that? You hear that? Come on, come on, you ready? And that's the key to being an atom, to become happy. Well, how do we become happy? We become happy by giving or taking electrons or by sharing them. Bonding. Bonding makes electrons happy. What they do is they're going to form those bonds by giving, taking, and sharing. I'll see you next time.